there's a couple of things in my career that's really hit me. One was my first hospital cooling coil when I saw that it had microbial growth on it. And because there's many that I've seen, I can say that that's quite common actually, unfortunately.
Wow.
And so I was really troubled when I saw that. And then the next thing I thought of is all of the workers in Australia, let's just take Australia, these people are going to work assuming that they're breathing clean air.
Yeah.
They really are. They're not thinking they're breathing. They're not thinking
the best.
it. Yeah, they really do think that. And so I like to think that we develop a social license around saying, that's not good enough. I mean, we're talking kindergartens, preschools, all the schools. It's all in the same category. There's a clear necessity to it.
Well, welcome back to the Let's Talk Facilities podcast. Today we have a great guest. I'm excited about this topic. I recently heard this man speak at an event I was at, and straight away thought, we've got to get him on the podcast. So I hounded him in the break.
Literally stopped me in the halls.
Everyone else went back inside to listen to the next session, and I was like, I've got to get you on the podcast, man.
True story.
So thanks, Zac Gilder from Steril-Aire. Thanks so much for coming onto the pod.
It's my pleasure to be here.
Yeah, look, I started getting interested in your podcast because I think, in having you on the podcast, because I think this is a topic that is, I don't understand it. I don't know a lot about it. But
it's complex.
Yeah, and as you were talking, you made it very easy for me to understand. But then I also got concerned. Like, just not only commercially.
It's a Pandora's box, and it's the rabbit hole, right? As soon as you start learning.
Yeah. So tell me, how did you get into indoor air quality? Tell me the beginnings.
Well, it's funny. I always like starting with this. I started in hot water. By that, I mean, we used to do heat pump hot water tanks.
Yeah.
This is 20 years ago. So we used to get...
that's early.
Yeah. It was right in the beginning. So I wanted to get into energy efficiency and something save the world sort of thing. And I saw this ad in a paper to go and represent them in Queensland. So I thought, this is great. So what it turned out to be is it's fully government funded. So the customer pays nothing at all. And you save about 50 to 70% of your energy. So that was my beginning. I started to do that with hotels, clubs, a whole range of other things. But when I first heard of this deal, and this really taught me about business cases and raising money, I know that a lot of people in facilities understand this. I thought, I'm going to get so many deals done here. I'm going to be a millionaire in 2 seconds. Yeah. But I had a free offer, and it was taking 3 and 4 months to get approval. So it really taught me about the process of how business cases get approved internally. Anyway, so I had a customer who said, do you have something else you can do to save energy? And I didn't at the time, but I went and researched it. And ultimately, I built up a supply base of about 50 suppliers.
Yeah.
And I used them to go into my customers to identify energy efficiency opportunities.
Okay.
Yeah, so and so what that led to was a thing called a peak demand project. And so with the peak demand project, you get rewarded when you take demand off the grid for a dollar value. And so we had the whole range of these inclusions, these energy efficiency inclusions that we had to use as part of that. They had to work though.
Yeah.
So this is where I had to develop a due diligence skill. So does it work? Does it not work? How do you determine if it works? Measurement, verification. So we had this big group of products. Then we started doing large projects. So these are several million, and we're getting hundreds of thousands of dollars in funding. And within those projects, we had this suite of products. And that's when I first got introduced to UVC.
Yeah, okay.
Yeah, because... So we're analysing it, but I'm client side. I'm looking at this going, does this stuff work? Like I remember one of my customers goes, you're going to shine a blue light in my air handler and that's going to save me energy. And
well, I've always wondered what does it actually do?
Blue lights, UVC is invisible.
Yeah.
So we were actually just at a carpet cleaning convention, funny enough, just on the weekend. And we actually just learned about UVA, UVB, UVC.
Yeah, well, I mean, UVC gets blocked by the sun.
Yep.
So UVC comes out of the sun. So when people say how old it is, it's as old as the sun. If it hit the earth, it's the germicidal wavelength.
Yeah.
So UVC inactivates RNA and DNA, so it stops things replicating. So if it did hit the earth, there'd be nothing growing here at all.
Okay.
So it's been studied for more than 100 years. So
Wow.
that's why its efficacy is really well proven. You get a certain microbe and then you get a certain amount of UVC called a radiance. So power, if you like, intensity, then you'll get a kill rate.
Yep.
So for example, when we're doing an installation for COVID, we can calculate the kill rate for COVID based on the amount of irradiance that we're generating and the time that we have.
Okay.
Yeah. So that's UVC though, in a nutshell.
So that's how you got into it. Wow.
Yeah.
And so the idea of this like indoor air quality stuff, I don't think I'd ever thought about it until COVID. And then it was we were all talking about this indoor air quality. Everyone's walking around with masks. We're buying filters for our home. You've got one.
I'm all about it. I've got a air scrubber with HEPA filters in every bedroom in the house.
Well, you're committed.
Ben's a germaphobe.
Yeah.
No. I like clean air.
Yes.
And you can tell the difference.
Well, we breathe 9 to 11,000 litres a day of air.
Litres
Of air goes into the body every day.
Wow.
So, and also when you said you like clean air, I mean, imagine saying the opposite of that. But that's literally kind of where we are.
But
I mean, but I'll walk into a building and sometimes it's like I can just smell the staleness of this air. Like
I could give you a job.
I
understand
there's no
what you're
air
saying.
movement.
I understand what you're saying. Well, you're actually probably picking up mold. You're probably picking up, it's a dampness and it's a feeling that you can get if you do it enough.
I feel like you need that air sort of turning over.
Well, that's very true because mold likes stagnation.
Yeah.
So if you have airflow, it doesn't like that as much. So that's one way that it can start to grow.
And this whole concept of clean air, like you and I were talking about this just before.
Yes.
And you saying that I like clean air.
Yes.
Like no one would say, well, I like to drink dirty water.
Correct.
Yes.
And you and I were talking about
dirty food. And so that's where we are. And right now, from our legislative side, there's just not the standards in place to say that you have to operate a facility with the highest level of clean air.
Yes.
Yeah.
They're just not there. So we have AS3666.2, which is about cleaning as required. But that's literally walking into an air handler and looking at a coil and then determining whether that needs to be cleaned. And but you can't do that. So growth on a coil can be fractions of a millimetre.
Yeah.
So you may not even be able to see it, but it's there.
Yeah. And so this is all stuff that you can measure. Like
Absolutely.
You could use a device and measure.
Absolutely. So what we used to talk about energy efficiency. That was the core of the product. So I'll just backtrack. The Steril-Aire idea was it was invented by a PhD in microbiology. His goal was to try and get rid of hospital-acquired infections. Yeah. And he followed the sort of microbial path to the cooling coil. And the cooling coil is the part in an air conditioning system where you're taking the heat out of the air. So the air is going right through a circle. It goes back up to the return air or comes in from outside. It goes through past the filters, hits the cooling coil, it changes temperature there, and then it goes into the space. So at that point, you get condensation.
Yeah.
So it's a very important part in the air conditioning cycle, and that's where you get microbial growth. Some of the growth that occurs in a cooling coil are on the WHO top 10 antibiotic resistant. Now what that means is when we run out of antibiotics, you're just not going to be able to survive if this microorganism's populating your body.
Yeah.
And they're known to be able to grow in coils. So it's a very serious issue in terms of what's actually can grow there and why it's growing there. But it's the water that's there. It's the water from the condensation that creates that growth. And most importantly, at that point, you get biofilm. And so biofilm is like a sticky matrix that sticks to the coils.
Yes.
And to your point of energy efficiency, so what it'll do is it'll block the coils. Yeah. And so you've got a fan that's trying to pull air through this coil and supply the room. And
so it just gets clogged up.
It's literally getting clogged up.
Yeah.
And so that fan now has to work harder. So the analogy I use is it's like vacuuming and you hit the curtain.
Yeah.
You listen to your motor. Doesn't sound good.
No.
That's exactly what's happening. But the other aspect of biofilm is that it's insulating the coil. So if you take, for example, the houses in Switzerland, you've got the soil and the grass on the roof, right?
Yeah.
It's designed to stop the heat moving. So it's an organic material, stops the heat moving. With aluminium, it's 1,000 times better at transferring heat than biofilm. 1,000 times.
Wow.
So that means that now you're making chilled water, or you're trying to cool your property. You're pumping that chilled water, but you're not getting cooling because you have biofilm.
Yeah.
So what we've done is we've measured the changes with airflow, pressure drop, and heat transfer, which are technical terms. But essentially what it is if you're going to design an air conditioning system, you need to consider these things in terms of how much cooling performance you're going to get. And what we know is if you remove microbial growth, you get significant benefits with energy efficiency. So what does that teach us? That teaches, one, that it was there, and it teaches that you can remove it and you can get those benefits out the other side.
But it was created not for that energy efficiency. It was created for hospitals.
That's exactly right. It was that was exact. So it went, and then a lot of the conversations I have, and again, facilities knows this. It's about often the money. How does that translate?
How do I save costs? How do
Where's
I reduce my
ROI?
energy output? Yeah.
So my early conversations were ROI, energy efficiency, and I think we might have mentioned I casually mentioned to a client that, look, you're also going to get some form of pandemic protection and air quality protection.
Here we go.
And
this is before COVID.
This is 2013.
Yeah.
And he stopped dead and he said, yes, Zac, there's going to be a zombie apocalypse. The world's going to be taken over by this mystery pandemic. Yeah. And I said, well, it could close your shopping centre. And we literally had this conversation. So that was the early days of IAQ. Yeah. That was a really good example of the early days. And why not? Because if you consider COVID and what that did for our awareness of IAQ, it's now become a lot more of a front and centre conversation.
Yeah.
You know, before it just wasn't.
Like I walk through offices all the time and they've got those Samsung, they're like this tall, those air filters.
Yes.
And it looks makeshift. Like you walk through these high-end offices and they've got them scattered everywhere. I'm like, this is an afterthought.
Yes.
Because your facility wasn't designed with the air quality in mind.
Correct.
Yeah,
and so it looks out of place. Are there things now, as people are designing facilities, are they designing with this in mind? Are you seeing that?
Well, basically, we've got a problem because the coil, because of condensation, so it has nutrient, which is lovely things like skin flakes, and all stuff coming from outside, and it's all being sucked back through mechanical airflow back to the coil where there is moisture.
Yeah.
And so we were talking about this at the Indoor Air Quality Conference a couple of weeks ago. How do you design a coil to not grow microbial growth? At the moment, the best way that we've found is to remove it and keep it removed. And that's what we do.
Yeah.
But it's a repetitive cycle. It's going to always be there. So at the moment, we need to accept that a cooling coil and a drain pan will have microbial growth.
It's going to grow, yes.
And we need to address it. That's that side, and that'll provide a much purer and cleaner air to the space.
Yeah.
The other side's inside the room as well. So when you have that Samsung unit, you've got an in-room device.
Yeah.
And so from my perspective, there's nothing wrong with doing in-room and in HVAC. But what we've learned over so long is if you don't tackle the HVAC, you're just going to keep pushing microbes into the room.
Yeah.
But if you're going to get that energy efficiency benefit anyway, you're kind of moving that into a different category. The in-room one, that's not energy efficiency. That is not energy efficiency. So it's a different conversation.
Yeah.
Yeah.
Absolutely.
And you might find that, say, for example, your split system there, you can turn that into an air purifier. So there's ways of doing it as well that don't need to be.
You can turn that into an air purifier.
Absolutely. Yeah. We would have a system we could put into a split system that would keep the coil clean all the time, but also make sure that all the air, because that air's, when you have a normal HVAC system, it's got outside air, it's got other feeds, but with this, it's going on itself, right? It's circling on around and around, like a cool room, very similar to that.
So it's not pulling. Sorry, I'm just now interested. All of a sudden,
no, it's just sucks it in like at the top.
Comes in the top and
spits
goes out the bottom.
I
And
thought
it
it was
goes-
coming from that big unit with the fan
No,
outside.
no, that's the condenser unit. So that's providing the chiller effect that goes through the coil.
I say this
You are-
nearly every
let us
podcast.
educate you.
Every podcast I say, this is like the idiot's guide. Like,
that's-
I feel like every time
but
I'm
you
just
know
like
what, though?
dumbfounded.
You're talking about mechanical engineering, and this goes to IAQ generally in this whole conversation. And what I've sort of had to understand, mechanical engineering and microbiology.
Yeah.
You have to get across.
Okay, so this unit's sucking in air.
It's circulating
recirculating
air. Yeah, and it's doing that because it wants to pass the air over the cooling coil
Yes.
to change the temperature.
Yes.
That's what the cooling coil does. But when
Okay.
it does that, there's moisture created.
Yeah.
And when that happens, there's growth created. And then when that happens, it matures and it releases into the room.
Right.
So with obviously the big HVAC systems,
Yes.
You'd put in your UVC lights, but they would also have HEPA filters, would they?
Not always.
Not always?
So what in a hospital we would be upstream, so in the air, in the flow
Before
of air.
it hits the coils?
Yeah, well, we're always just after the coil.
Yeah.
So that's where the condensation's happening. That's where the drain
That's where the
pan
growth
is.
of that biofilm.
That's right. If you see the drain pan, it's like a little swimming pool on the other side. Language for you there. Little swimming pool on the other side of the coil, and that condensates, and that can be a huge amount of water actually.
Yeah.
But that's happening on that side because it's the last point. As it releases from there, it's changed temperature.
Okay.
And now it goes into the duct.
Just out of interest, how much water could that be in
It's
a building?
thousands and thousands of litres.
This is, I don't know if
And
you
you can
listened to
reclaim it
episode
too.
1 or episode 2 where Colin shares about being stuck in a lift. That's the water that fell on him.
I wouldn't. You know what would have probably happened is that the condensate drain pan would have got clogged with microbial growth. We see this all
Yes.
the time, and so the condensate still comes, but it overflows.
Yeah.
So the drain pan
one of
wants
our
to grow.
owners was
He
stuck
thought he
in
was
a
going
lift,
to drown.
Oh, is
and
that
the
right?
lift started filling up with water.
Well, that'd be that. I think I've seen a movie like that.
It was crazy. He thought he was going to die.
Yeah.
Anyway, so back to the split system air units.
Ben's going to be getting rid of all of his air filters. He's going to be
There's
turning his.
still a place for HEPA filters.
Yeah.
I
You
think.
mentioned HEPA.
So
yeah.
obviously you can't fit a HEPA filter to a split
No,
system.
and it's overkill as well. So if you look at the application of HEPA, it started in a hospital environment, and then post that HEPA, you've got a surgery, and so it's got 99.97 efficacy. One of the problems with HEPA though is that it's a filter that captures, and because it captures, the growth can actually land there and keep growing.
Yes, that makes sense.
It also gets thicker and gets harder to pull air through it. So a HEPA filter is like an FP15. It's a very thick filter, which means you need to have a lot of fan power to pull through it.
Yeah.
So what we've found is if we're upstream of a HEPA, we can make the HEPA last longer because it's now not having to deal with that microbial load that it was previously having
so
to
you
deal
could
with.
potentially put UVC at the top and the bottom, basically.
Well, you'd only need to do it at the coil. You don't. We don't.
Sorry, for a split system.
For a split system, you'd only need to do it at the coil. And in that HVAC system we're describing with a HEPA downstream, you do it upstream of the HEPA.
Yeah.
And then your HEPA lasts longer, and also it's more efficient because it doesn't get blocked as fast. But let's go back to a
smaller facility. Not as large as a hospital.
well, let's just say a shopping centre or an office building.
Yeah.
Yes.
And people just don't understand that when the coil, from that coil point, anything that's produced from that coil is going down the duct into your lungs, and there is nothing there. And that is, and I have to say also in hospitals that aren't in critical environments, all the general areas, there is nothing there. There is nothing there, and the growth is there as well, and I have seen it. Wow. So the HEPA
What does this growth look like? Can you see it?
It's actually but not always.
Okay.
So it can be brown. It's going to sound like a very interesting conversation. It can be brown. it can be crumbly. It can be green, black, shiny.
Wow.
So every building has a microbiome. So microbiome's like in our stomach, right?
Yeah.
Every building, this room,
And it's always
room
unique to the
is
space.
very unique. Yeah. So what you'll see is you'll even see unique microbiomes in different AHUs within one shopping centre.
Wait, what's an
There'll
AHU?
be different. AHU is an air handling unit, which is a giant air handler or giant split system, essentially.
Yeah.
So you can walk into these and you can see different growth on different units. So it's that it can become that granular.
Yeah, wow.
But so microbiome is in every building, and so you're going to get different growth in different buildings. It's going to look different, but you may not always see it. And a lot of people say, oh, well, that means if it's based on water, maybe it's everywhere that there is water. For example, in far north Queensland. But we have a lot of evidence from Canberra, from Melbourne, South Australia, Darwin, and it's the same thing.
Yeah.
So what does that tell you is that the growth is there. It just changes its consistency. So biofilms are an absolute beast. So what they'll do is they'll form a shell, and then you'll hit it with a biocide, and it will learn next time how to overcome your biocide. Seriously. And one of the reasons why I know this happens is because
living.
We've done 100 case studies. Why do we always get a result? How? So that means the biocides have a limited effectiveness. They're doing something, but they're not getting rid of the biofilm completely. And now science is telling us that's what's happening.
So currently, if there is no UVC light in a what was it called? Sorry,
air handler. AHU.
So there needs to be periodic maintenance to clean it out.
Correct. Yeah. So and then you'll come in with a biocide, but one of the problems is that there may not be an airflow pressure drop or heat transfer test, which is your effectiveness of that clean. Did you actually get those? And particularly indoor air quality, because bacteria is doubling and mold, they're doubling in minutes. You know, so you get the calculator out and start seeing what that means.
It's exponential.
It goes crazy very, very quickly.
Yes.
So as soon as you finish cleaning, it starts growing again. So this is why I got attracted by the perpetual nature of UVC. It's never not doing it. It's always killing it. So the biofilm cannot survive in that. It's impossible.
So what's the efficacy rate like of UVC on?
Well, we know from when we do our energy efficiency, so there's a whole range of ways you can look at it, but if you do energy efficiency, if that coil goes back to design, which is when you installed it, it had X amount of litres per second as your goal. When it's got blocked with biofilm, it's now down to X minus 20%. Then you get rid of the biofilm and you're back up to design. It's like a brand new air handler.
Okay.
So basically you know that that's been removed, and then you know that efficiency has been created. It's a very important way of doing it without any smokes and mirrors.
Yeah.
There's no way that can be removed, or there's no way that can change if that wasn't a problem.
If it wasn't removed,
If it wasn't taken away, the airflow can't change, or the heat transfer. So heat transfer is super important because you're trying to get as much heat removed for the total runtime of your total cooling plant. Every facility manager in the world is trying to do this. It's number one, energy efficiency. Get as much heat as I can get out for the least amount of energy consumed from my plant. So they'll throw around COP, which is how much energy am I using to get rid of a unit of heat. And you want to use as least amount of energy as possible to get rid of a unit of heat. But people don't think of the coil. They're thinking of the system where it's got an electrical input. They're thinking of the fan. And I'm sure if we had this conversation...
I've never thought of the coil until I heard you talk about it.
It's an inanimate steel object that you would just think that everything slaves to the coil.
Think of the coil.
And honestly, you'll get into arguments with people in the industry because they'll because they heat transfer as an energy efficiency, so if it's not even recognised, and we're talking 20%, at the max, but it's a reliable 10% of your total AC plant.
Yeah,
the numbers are huge.
So the coil is sort of like a filter in a way.
It is. It's a lung, but it's a heat transfer point.
Yes,
it is purely a heat transfer point.
But the more stuff grows on it,
correct,
that air still has to filter through it.
Correct,
and so it is
correct.
Yeah.
And it will and all of the new nutrients that come hit that biofilm and make it stronger and more intelligent. It learns how to deal with what's outside of it, and the inside shell gets stronger and tougher.
We
it's like a big party.
Oh, it really is. Yeah.
Yeah. Well, we go into businesses all the time and talk about the cleanliness of their floors, and something can look clean on the outside. One of the things we do, like it's a gimmick, but it sort of shows, because we talk about the carpet plays a role in the indoor air quality.
Absolutely.
And it's like an ecosystem where we have different areas of the building that we tweak and we clean to make sure that this indoor air quality gets lifted. And so we make people close a door to one of those little tiny office spaces and we say, leave this door closed for the next 24, 48 hours. Leave your aircon unit running. Leave the HVAC going, and we'll come back and we'll look at it.
Yep.
And when they come back after that 48 hours and open the door, if it's a lighter colour carpet, you see this dark grey line. And so the air's been pushed under that door through the carpet fibres. And so you see, okay, well, this is what the quality of your air is like.
That's fantastic.
And the problem is the carpet's trapping all of that.
Yes.
And so that's why we say we need to clean this more regularly. We need to be proactive. And so it's the same with those biocoils.
That's right.
That growth is happening. What we're seeing under the door is happening in a place we can't see.
You've also got there'll be a biofilm in the carpet, or potentially in the carpet. It'll be another microbial community.
Oh, we should start testing.
This is the microbiome thing, right? So it's and there's lots of papers written on this as well. So this is the furnishings are part of the source of microbes that can potentially be and potentially can be a very significant source. So and when you walk, they and it aerosolizes.
Yes.
So bacteria, or particularly molds, they want to jump. So they grow, they mature, and then they go looking for a new home, and they keep jumping. So they want to be airborne and move around. So when we're walking, we're actually disturbing them.
It was interesting. We recently were at a Work Health Safety Expo. We put up a video of carpet that had been cleaned by using our encapsulation and then cleaned with steam cleaning or hot water extraction. And when you hit the carpet under a light, that had been cleaned with a harsh light that had been cleaned with hot water extraction, you could see it. The same with our encapsulation. You hit it and there was just nothing, because the encapsulation that we use is 98.5%. It removes the particulates, the contaminants, whereas when you do hot water extraction, you can only get max 75, 80% out. That's why it stays damp.
Yes.
And so that's growing
It's a very
stuff.
similar message, because when I was talking about my big early career, due diligence is something I really enjoy doing.
Yeah.
So it's talking about, does this really work? And for me, and I think you guys are the same. Like if it doesn't work, imagine being behind something that doesn't work.
Well, yeah.
Or it doesn't work as well as it could do, or if there's something that would work better.
Yeah.
And that no, just do this.
But all that to say, so only having been in the industry a couple of years, I started freaking out about my son going to school at a primary school and sitting on the carpet.
Yes.
But now I'm thinking, well, they've got the air conditioners. Basically, I want to put him in a bubble.
He'll be outside, right?
Yeah, you're going to learn from out the window.
And that's such an important point, because we're at this point where, okay, we have this issue that we know about, and so experts have studied indoor air quality.
Yes.
We know that there's a need to change it, and we're all intrinsically, we just get this. People are getting it. So, but to get legislation and to get change is going to take some doing.
Yeah.
We were at the Safer Air Project launch last year.
What is the project? What is Safer Air Project?
Safer Air Project, Plumstone has done such a great job. So in Australia, and this is a great pub bet, how many people suffer from a chronic condition on the basis of a percentage basis?
I know the answer because you said it. That's what I heard, but I was blown away.
It's an amazing statistic.
Do you know?
No.
What would your guess be?
Right, so what was
how many people out of a percentage of the total population of Australia, how many would have a chronic condition that would be negatively affected by bad indoor air quality?
Oh, well, I don't know, maybe 15%?
15?
Yeah.
Nah, it's 1 in 2. 50%.
1 in 2.
Really?
1 in 2 people.
50%?
ABS statistics.
Wow.
So one of the things that the Safer Air Project is advocating for, and we met the Assistant Health Minister, Ged Kearney.
Right now, one of us have a chronic illness that we don't know about, basically.
Well, it'll be well, actually more than 1.3.
Yeah, 1.3. So one of us and then a small portion of one of the others.
I think it's going to be the case. What Plum's done is she's got together all experts, economic experts, political influence, industry experts. So Professor Lydia Morawska is a worldwide at a QUT, and she was one of the people that was pushing for the recognition that COVID was airborne. May have been doing the same thing, but anyway. And so
at the start, that wasn't recognized.
Well, we were washing hands.
Yes.
We were washing hands. I mean, I was having conversations with official people, and they were saying back to me, "No, we're washing hands." And I'm
using hand sanitizer was installed everywhere.
That was where the science was, and so she did a lot to drive that. And so now it's really great that the indoor air quality movement, if you like, has changed so much. So ASHRAE 241 was a huge step. That's an American thing which talks about infectious aerosols. And so where we're heading, the good news is we've got technologies to solve the problem. We also know that if you have this space, you want as least amount of pathogen per cubic meter in this space as possible. That lowers your risk. And the lower the amount of pathogen in the space, the lower your risk, and the lower your risk, and the lower your risk. So when you're sitting on a bus and the windows are all fogging up and it's completely packed in there, and you are breathing so much of other people's, and this. So in this
conference we were just out on the weekend, they took us on a day trip.
I was thinking this the whole time.
The windows on the bus kept fogging up, and every time we stopped for a toilet break or something, Ben would be the first one off the bus and he'd say, the air was stale.
I need to get into indoor air quality.
You instinctively know that there's a problem, don't you? You instinctively know there's a problem there.
I didn't.
Well, but when you're in that environment and it's sort of thick.
I don't like the smell of it.
And so what about if you're in that environment and someone starts coughing? Because then it gets very obvious.
Someone starts vomiting. I was going.
Well, they're more particles and So one thing that really there's a couple of things in my career that's really hit me. One was my first hospital cooling coil when I saw that it had microbial growth on it. And because there's many that I've seen, I can say that that's quite common actually, unfortunately.
Wow.
And it's because of the Australian standards not saying that you cannot have that there. So there's a big gap there, but that's that part of it.
Yeah, and that's why this UVC stuff was sort of brought about, so that we wouldn't have
you want to remove it from that point. You want to remove it from that point. I mean, hospital-acquired infections kill 100,000 people.
Yeah,
it's their numbers are big, but indoor air quality issues kill millions of people, worldwide, and cost the Australian economy $12 billion. There's some really nice angles where it's going though. So if you have better indoor air quality, you're more productive. So
you'll think more clearly.
Yeah.
Right?
So what I'm trying to do in my conversations with customers is bring them back to what I call bums on seats. What do they care about?
Yeah.
And if you want your HR or you want your team to be really productive, you care about indoor air quality for their productivity. And Harvard have done studies and said that you can get a 15% improvement in productivity.
Yeah.
Think about that. That's an hour a day, for an office worker that they can generate that much more output, even though they're sitting at the desk the same amount of time.
A tech company I know, they had this huge sales quota for one of their months. They were trying to achieve this record for their business, and they did for one of the days of that thing with their whole sales team, they brought in oxygen bar, and so their sales reps all got half an hour at the oxygen bar, and then went back to work, and it was all to do with this. If you're breathing clean air, you're gonna be more productive.
It makes so much sense.
Yeah.
So it's like lung function or anything like that. So I was really troubled when I saw that, and then the next thing I thought of is all of the workers in Australia. Let's just take Australia. These people are going to work assuming that they're breathing clean air.
Yeah.
They really are. They're not thinking they're breathing. They're not thinking
it.
Yeah, they really do think that. And so that I like to think that we develop a social license around saying that's not good enough. I mean, we're talking kindergartens, preschools, all the schools. It's all in the same category. There's a clear necessity to it. I'll give you one other example. So in the Safer Air Project, there was a doctor there that had, at the time last year, had breast cancer. And she knew that her immune system was very weak and knew the whole...
She's corrupt.
Well, she had to go in to get chemo, but she also had to realise that if she went into a hospital, she could get an IAQ, a HIA, and end up possibly dying from that.
Yeah.
And so she literally had to weigh up. And so this was in the Safer Air Project launch, I was fuming.
Yeah.
Because I felt that is so ridiculous. That choice.
There's the emotional element
Very much
right?
so.
Like that's the human element.
People get sick in hospitals.
They do. But that's a conversation for another day. It's a big conversation, but it's true. It's true. And but so what are we doing to make sure that we're mitigating that risk? And so I think there's a logic. The secret is to approach indoor air quality from the tangible benefits.
Yes.
It's what we've been doing for 20 years. Talk about energy efficiency.
You were doing it before it was cool.
A long time.
You're loving life.
Just do the maintenance. Talk about maintenance. You don't have to do your maintenance. Talk about energy efficiency. The indoor air quality is often an uncomfortable conversation because if it needs to be fixed, it wasn't fixed. Duty of care, there's all these other issues coming up.
Yeah.
But we've evolved, and so my advice for people running facilities is just to think that this is not how it used to be. Yeah. People generally know about indoor air quality. The experts are telling us there's a problem. Other jurisdictions like America are coming up with code. There's logic to do this anyway.
Are we coming up with code here in Australia?
We're starting to work on it. We're starting to work on it. But these things take time.
Yeah.
Well, we just did 1668, which is about reducing outdoor air if you filter. So if you look at the narrative, it's all about filtering. So this is what UVC does and what HEPA does. And there'll only be a few technologies that you'll sort of be able to draw from.
Yes.
That will filter the air to provide less pathogen in a space. That's where you're sort of generally heading. Get rid of the growth that's on the coil so that doesn't become a source, but also anything that's been drawn in from outside or back in from the space, you want to try and purify that as much as possible. Yeah. Then you're way in front of where you are now, because where you are now most likely is kind of nowhere.
Yes.
But that's not your fault. And so one of the things that when we're talking to facilities, they're meeting code, they're doing what they should do. I'm not trying to tell you what to do. I'm not trying to tell you you've done a bad job. I'm not pointing the finger.
No.
We're just saying that there are a few better ways to go about this now.
Well, and it's not that they've done a bad job or like they just haven't. They're in the unknown.
That's right.
And when we're in the unknown, you can't be responsible for that. But
that's exactly
now, what is there's a Brooke Fraser song. She won New Zealand. Now that I've seen, I'm responsible.
Yeah, yes.
And now I know
exactly
this.
Right.
What am I going to do about it?
That's exactly right. Well, as professionals, that's what we all stick to, right? So if we work around an electrical, if we go to do something electrical and we see the board's unsafe, we have to talk. We have to say something.
Yes.
Yeah.
So this is where we are. But so there'll be motivations, I think, to do it anyway, sort of thing. But I think
But why not be a trailblazer?
Well, this is then you look at a lot of the narrative of businesses, and this gets into the greenwashing conversation and all that. Like, how much do you really? I mean, if I'm going to be sick if I read another innovation in the first paragraph of a big company. We innovate, we look after our people, you know, and okay, yeah.
You know what what would be great actually, not just for what you're doing, but just in general, is if there was like a certified sticker that you could put on the entrance to a building and say, certified,
certified clean air. Certified clean air.
We do that 99.9%. Yeah, we do that. Yeah.
Yeah. Okay.
But there's an issue with talking about this publicly. There is an issue because what was it like before? Oh, are you admitting you had a problem? I know I can hear all the legal teams.
Yeah.
But that's always the case.
It is always the case.
As we grow and evolve as society, we're always learning new things where, we weren't doing that well before, but
that's right.
We're not responsible for it because we didn't know.
That's exactly
good
right.
Place to work company. I think that's what it's called. It's like what? So before you were certified, you weren't a good place.
Yeah, well, that's kind of where it is, and so that's where the legislation makes it comfortable.
Yeah.
So that businesses are able to move with at that point, but there's so many reasons you want to do it anyway.
Yeah.
that have been fundamental to how we've operated, that you don't have to really bring that in. You just need to consider it. And
it pays for itself anyway, from what I heard you talking about with this energy efficiency.
That's exactly right. If you
you're
do it
saving the money here.
Yep.
So there's an ROI.
Correct. Yeah.
So practically speaking, so a facility, say a shopping centre, an office, they have the those units.
Yep.
What do they do?
So every time when it comes to UVC, you've got to do a tailor-made installation. So you need to know the coil face, which is the dimensions of the coil, length and height, and how deep the coil is.
Yep.
And from that, you can get in a radiance calculation. And this is what we talked about off the top, right? So UVC is based on intensity and time. So you need the correct irradiance. If you don't have the correct irradiance, it's got to be powerful enough to operate in a cold moving environment. So you do a specification, and before you even install, we do an end of life specification. So after 18,000 hours, we know the kill rate, and that's what we give to the site, so that they now know for that 18,000 hours, which is 2 years nonstop.
Yeah,
they get that kill rate, and that kill rate will mean that there's no biofilm, that they have the indoor air quality improvements, and it's all built into it. But it's got to be done on that specification.
Yes.
So that we've done that with Aire, so DA15. So it's got it at the furthest edge of the coil. You've got to have a certain irradiance.
Okay.
And once you do those things, then you can emulate case studies that we've been able to get over and over. So UVC is about intensity. If it's too low intensity, it doesn't have the kill rate. It will if it's on a surface over time, but not in the air.
Yes.
So the combination of the ability to do it,
and that's purely because of the volume of air that's moving through it.
Yeah, the volume, the speed. So air at the coil is the slowest part in the whole system. It's 2.5 meters a second because it slows down through the filter, slows down through the coil, and then accelerates again. So it's a really nice time to kill everything.
Yeah.
Don't often say that, do you?
But it makes sense.
In this context.
But please don't take that out of context.
Cut this out and put it out there on LinkedIn. Listen to what Zac said.
That's the opener.
That's the grab. Yeah, fantastic. So that location, and that gives you that, and so you're going up the coil. So the air's coming through the coil. So the light's going up the coil and also back the other way and also up and down. So 360 degrees.
Yeah.
So that's super important. And then because what you want to, just the same as what you guys do. So you want to make sure that you're getting an actual result. And the only way you get a result is you've got to follow what's worked before.
Yeah.
Yes.
And so what we've worked out that if you do this, you'll get these case studies. And that's no matter what we're given before. So it doesn't matter how you've treated the coil before we turn up.
Yep.
We'll do this before and after, and then you'll be able to determine that there's a definitive change each time. But it's about the output. And quite frankly, the invention of the product was how do you get UVC to work in cold moving air? And that's what differentiates the product that I'm associated with. Because what happens with UVC, it drops off substantially in cold moving air. We're talking it goes down by half.
Oh, really?
Yeah. So if you don't have the ability to withstand that cold moving air environment, the customer can think that they're getting this, but they're getting that.
Yeah. Okay.
Yeah. So we're all about outcome. And this goes back to my roots, which is about what works, what doesn't.
Yes.
If it doesn't work, I don't want to know about it. And so now what we're really saying to customers when they've got no more last resort. So because I was at an army barracks the other week and they're spending a lot of money on mold remediation. There's a lot of problems. And they kind of don't know what to do anymore. And I'm rubbing my hands together because I want to be right in that battle.
Yeah.
Because if you can't solve the problem, if you can't get a final solution, it's the same. Please don't take that out of. If you also, but it's the same with you with you don't want to leave a carpet that's kind of clean.
No.
Yeah. It's just, what's the point in that?
Yeah.
It doesn't make any sense.
Yeah.
So that's in that. And then your customers aren't coming to you because they kind of want you have a try at it.
That's right.
Well, that's kind of what happens in our industry. Yeah.
Really?
Yeah.
So let's say there's a facility manager out there. Actually, two questions.
Yes.
Facility manager out there who's listening and now has gone, gee, my unit at home. I just want to know what I want to do at home.
Yeah.
For our office, we've got split systems. Like I'm thinking,
We don't have the big HVAC units at the office.
Yeah.
I don't have them
Just
at home.
split systems.
So number one at home, is there something I can do?
There is, yeah.
You can come over and put a UVC
I'm not
light?
sure if I'll actually come over. But
I'll make you dinner.
You can install it in 20 minutes. So you just turn a split system into an air purifier.
Okay.
Yeah.
And so, there is a product
Absolutely.
that I can use at home.
Yeah.
What about a facility manager? They're looking after a building.
Yes. So tomorrow I'm going to a building in Brisbane and I'm going to assess that building. And the only way we can do that is to walk into, and we've done it for 20 years, physically check your property. Why is that your responsibility to do my work? So I've got to go and look at it. I've got to know what's there.
Yep.
Then I can do my radiance calculations. And then I can make a promise of performance.
Yes.
So it's really just get in touch is the simplest thing, and we take it from there. And what I've done most of my career is business case creation.
Yes.
So I've worked with a lot of national ops guys and girls trying to get business cases signed off, and it's been an incredible journey. And I'll just tell you one story there.
Yeah.
We did a project. It was several million. It had 27 signatures on this contract.
oh my goodness.
The last signature wasn't there. And the national ops, he'll know if he's listening to this story. The national ops guy got on a plane to Perth, and he saw the lady that he needed to get the signature off. She went to the bathroom and he put either hand outside the door and waited for her with a contract. Yeah, on it. And so getting business cases over the line is really difficult.
Yeah, and facility managers face that a lot.
They do, and so I really like working with them, at that site and the national level, trying to, because it's not just as easy as going, they want to purify there or they want energy efficiency, but then there's that, how do you communicate that?
Yes.
Yeah.
So I really like that story. He rang me at 10 to 9 on a Sunday night and told me that he'd got, the
last
when
signature.
he was in Perth. So we're good to go on this project. And he says, so that's what I like about you, Zac. You're the only person I know to answer the phone at 10 to 9. And I say, that's what I don't like about you. You're the only person who rings me at 10 to 9 on a Sunday. What are you doing?
Yeah.
But I answered. But anyway.
It's good news though.
Yeah, no, it is. It's great news. But there's a lot. That's the question of what do you do when you're a facility manager? Because it's one thing to say, oh, let's get a quote, but then you've got to then present it.
And we are our sales team and who are meeting with facility managers all the time. It's not about us selling our product or our service at the end of the day. It's about how do we make you the hero as the facility
100%.
manager. And so what you're doing really is, like, if they come to you now, they might not have a C-suite member that's willing to sign off on it yet.
Yep.
But they're hearing this, they're going, gee, I want to make sure that when I have to be in the facility 7 a.m. till 6 p.m. every day to look after this building.
Well, they can initiate.
I want to make sure that I'm breathing clean air.
That's exactly right.
So they can contact you, get you in, assess it. You'll help them build the business case to then take it up the line.
Correct.
And they'll be the hero at the end of the day.
That's exactly right.
Because they were the ones who said, hey, this is an issue.
That's exactly right. And we know,
No C-suite members listening to this podcast, but they are.
Well, you never know.
facility manager
And
is.
look, I've got a lot of respect. I know this would sound like I'm not going to use profanity, but it's something in your pocket. But I'm not trying to do that. These guys are so busy. They're so busy. Have you ever spent a block of time with them and what they get called out to do?
Yeah, they're getting called out to do things that don't even matter.
So you've got to make their day better.
Yeah.
That's something I recognise so way back in the career. If you're a pain in the ass, excuse my, oh, there you go. There's some profanity
there
for
you
you.
go. I had someone say the penis.
Did they?
Someone
just did.
I feel like we might need to bleep that.
But yeah, if you recognise just how much they've got to do. So and that's the same with the national ops guys. I mean, the guys I work with, they've got $500 million budget annually, so they don't need anything that's not straight and clean and easy to work with and call them back and all that. So that part of it I really like. And I do have a lot of respect for what they do. It's super hard.
Yeah.
I mean, it goes from the carpet to a light fitting to something happened in the car park to a security issue.
They're spinning plates like a little circus performer all the time.
And then National's giving them no budget.
Yeah.
And then but they go and say, why haven't you done this?
Yeah.
And it's a difficult
Why
job.
isn't the coffee machine turning on today? That doesn't matter as much as my air quality.
A lot of the times they're rewarded for not spending money.
Yes.
And that is totally the antithesis of indoor air quality improvement.
Yep.
So if you are trying to do the least, well, you're not going to improve indoor air quality. If that's your goal, but quite frankly, I'm not excited to work with these people. If you're just trying to do the absolute bare minimum, it's just not my.
We say that all the time. We're not,
and you can tell those.
Yeah.
It's like you can tell when someone cares and when there's just it's just a job for them.
I think so. You know what I mean? Yeah.
I think to sum it up, I think something that you made me think about just before we pushed record was that we get told, like you see those sort of not-for-profit commercials, charity commercials that talk about, well, you can last this many days without clean drinkable water. And we're trying to fix the clean drinkable water problem in so many third world nations. You can go this many days without eating food. And so we're trying to help orphanages and be able to feed these starving children and the epidemics around the world. No one ever talks about, well, we literally breathe how many times a second?
Yeah.
How long could you go without breathing? You can't last very long.
It's a minutes thing.
And that whole idea of, well, then is the air that we're breathing clean? I'm scared by this concept.
I mean, we've done a good job with outdoor air. So in Australia particularly, we've tried to reduce particulate.
Yes.
And we've got code on outdoor air, and outdoor air does get drawn into indoor air. So we've experienced benefits from that, and if you compare that to other countries, significantly different. But indoor has its own, as we've discussed today, it's got its own nuances, the microbiome, the biology
its own ecosystem.
Of it. Yeah, that's exactly right. And then there's humans in there, and that's all circulating. We've got to remember that this built environment that we've created is very new, and that aircon is very new. And it does coincide with some health maladies.
Yeah.
If you look at the humanity, there's a little bit of a coincidence. I mean, fast food is part of that, but there's a coincidence between us being inside all the time and our health overall.
I hear one person at a desk in my office cough, and I'm like, why are you in the office?
Well, it's become like that, hasn't it?
Yeah, but back in the day, that wasn't even a question before COVID.
You know what it's become? It's like it's the new drink driving.
Yeah.
So do you remember, I'm old enough.
I'm not going to get demerit points.
I'm old enough to know that it wasn't a thing.
It wasn't a thing.
Yeah.
But now it's a right alive.
Now, people who are against it are mostly social people. Like, what? You shouldn't be doing that.
Don't
drink.
What are you doing? What are you doing getting behind the wheel?
Yeah. So that's the social license.
Yeah.
It's got a social license to it. You know, people will stop you. Aaron, no, you're not getting in the car, mate. No.
Yeah.
That's the social license.
Yeah.
So now we need that same sort of mentality around air quality.
Yeah, it's like, Aaron, you're not walking into that moldy.
You can't. Don't go in there.
Do not go in there.
Don't go in there.
Why didn't you let me get on that bus?
Well, we didn't have a choice, did we? I needed one of those Dyson hair purifier
That's
things.
it.
It's well, of course, you can purify the air in a bus, a tram, a plane, a train. You can do. It's all the same thing because it's all relying on aircon.
Yeah.
It's all resets and this conversation is the same every time.
So how do facility managers who are listening, who are like, gee, I just need to get my home and my facility, my building clean, how do they get in contact with you?
Probably through my email or phone number. I don't know if the
We'll
details.
link that at the bottom.
Okay, great. Yeah. That'll be the easiest way to do it.
We'll tag you in on
happy
LinkedIn
to look
as
after
well.
them. Yeah. And even just have the conversation. Because a lot of that is that. Like, does this work? Why? Where could it? I'm not sure. My system. I have pack units. Of course, we do packed, fan coil, HUs, giant HUs, tiny HUs, splits. Doesn't matter. So we modulate. The system modulates, so it doesn't really matter how you're doing it.
Yeah.
But
and in terms of ROI, you gave a number the day I heard you talk about a really quick number, which was, okay, it'll take you this long to pay off the unit just with what you're reducing the energy.
Correct. So we see a 2-year ROI is very reasonable, and below 2 is definitely there. On the fan only, we see if you've got a VSD, you can get down to 2.5 and just on the fan.
Just by
on the fan.
Reducing the energy that it's taking to run
the unit. But if you include the chiller, which is the condenser or what's making your chilled water in the background, if you include all that together, your total AC reduction cost should be 10%. So that's on your total
Yeah.
energy cost to produce cooling in your building.
Which you're doing anyway.
You're doing anyway, and energy efficiency as a goal is definitely a good goal.
Yeah.
There's still a thing, this big globe that we roll around on that is worth trying not to.
Yeah.
Try and pull a little bit of carbon out if we can do it here and there. So there's a motivation there. But yeah, that'd be. But have the conversation, because UVC seems a little bit, like I said to you, like going to shine a blue light.
Yeah.
What the? Yeah. So it seems a bit like that. But
Seems new age.
So more you dig into it, the more solid it gets, and then that's why I've been involved with it for so long. And you just keep digging, and you'll just keep getting evidence, and you'll realize, okay, there was a problem. You can solve it.
Yeah.
And that's probably the final thing. Don't suffer unnecessarily.
Yeah.
Because a lot of people are out there with mold issues, with repetitive clean issues, and not sure what they should do. Rely on our expertise, and I would say that to as suppliers generally, as someone who had 50 that who used to work for me.
Yeah.
Ring guys like you and I and ask us questions. We're going to help anyway.
Yeah.
That's what we do. And even if you don't do anything with me in business, I'm going to be talking to you.
Yeah. Well, one of our owners, Colin, a lot of what he does is mold rectification, going in and helping companies that their facility has mold.
Yes.
And it's just everywhere. And so knowing this, I reckon Colin will like hearing this, here's another expert to bring into that equation.
Absolutely.
Because we just didn't know about it before.
That's exactly right. Yeah.
Thank you so much.
It's my pleasure.
Thank you.
I'm going to listen back to this.
I can't wait to get one of these things in my system. That's all
Me
I've got in my head.
I'm buying one. As soon as we stop recording, I'm finding out where to get it. Thank you so much.
It was a pleasure. Really
Thank you.
enjoyed it. Yeah, thanks for having me again.